we'll kick it off because I've got a few bits and pieces to say, and I think Des wants to say a bit and pieces as well. So we'll kick off and hopefully folks will join in. But thank you everybody for giving up your evening and coming to the Glasgow Azure User Group. I think this is meetup number 25, which is just mind blowing, considering we've been running since 2017. And yeah, I've lost count how many virtual meetings we've had, but here's hoping that's going to change in the future, but we'll see what happens. For those are newbies, I think most people know who we all are looking at the names. We've got a lot of regulars tonight. The user group is all about community focused, and myself and Gregor are the organisers and the people behind all the tweets and newsletters and quizzes and all the stuff that you see. If you've got any questions, if you want to speak at the meetups, if you want to do anything with us, any suggestions, any topics, please do reach out to us. We're both here this evening, and you can obviously get us on Twitter as well. In terms of code of conduct, we do have a code of conduct for the user group. We do want this to be a friendly and welcoming place, so please everybody be considerate, be respectful. If you do have any issues with anybody at a meetup, again, myself or Gregor are available to chat to, and we can deal with whatever needs to be dealt with. But hopefully so far everybody's been really friendly and patient with each other, so it's always a good community that we have. So we are thankful to a bunch of people and companies for supporting us and sponsoring us. Most of the names on here have probably sponsored us since 2017 and have continued to support us and help us grow the community and be able to provide stuff. Long gone are the days, I think, of stickers and pizzas and beer and stuff at the moment, but these companies still help support us and stuff like that. As I said, Des from Servent is here tonight. Des, do you want to say a few words?
Yeah, absolutely. Thanks, Sarah. Hi, everyone. Most people know me. For those of you who don't, my name is Des McGuire. I'm the founder and Azure Solutions Director at Servant. We're an expert Azure partner based in Glasgow, work across all of Europe with Microsoft customers. And with me today is one of our architects, Nathan Bird, who's going to just say a few words around what some of the AVD, I know I say WVD there, some of the AVD projects that we've been working on. And at scale, you know, we're talking tens of thousands of users in these projects, and Nathan's going to say a little bit about that. But before I do that, I'm just going to flash up the screen. Sarah, if I can just take control here. Just to say again, due to continued success, we are hiring across a number of roles. So we're looking to speak to anybody from a developer background for an Azure architect role, anybody that's either a cloud architect and want to move into that role to do enterprise scale Azure projects, any cloud engineers or budding cloud engineers, then we're more than welcome to speak to you as well. And last but not least, any solution salespeople who've been selling Azure at an enterprise level, we're keen to speak to people that have that skill as well. The roles are permanent, fully remote, at least 2 years enterprise scale Azure experience. Hit me up on LinkedIn, Twitter, or even on the email there, and I'll have an informal chat with you. So thanks Sarah, thanks for the opportunity. I'll hand over to Nathan.
Yeah, hi guys, I'm Nathan Bird. The other thing is you get to work with me. So if that floats your boat. Yeah, I'm a cloud architect at Servant, work for Des. Been in the role nearly 2 years now. And amongst other things that we focus on, latterly Azure Virtual Desktop. And not in particularly what is Azure Virtual Desktop, we're assisting customers at enterprise scale, and this ties in nicely to Gary's talk, I think, on how you automate a lot of these deployments and push the boundaries of Azure Virtual Desktop. So always keen to speak to people that are doing that type of stuff, whether you've got a VDI background and you're not doing Azure Virtual Desktop in particular, you know, playing things off against the likes of Citrix and things, and messing around with Azure DevOps pipelines and GitHub actions and things like that to automate a lot of these processes and take away the management headache that a lot of customers are challenged with when they take on an Azure Virtual Desktop adventure. Yeah, so we've got multiple customers in the tens of thousands at the minute, scaling up into Azure Virtual Desktop. And yeah, if that floats your boat and that's what you seem that once you want to get into in the future, and that's just one of the things we're working on. We're doing a lot of enterprise scale landing zones as well for customers. So getting Azure environments right from day one if they're greenfield, and getting them into shape if they're brownfield. It's not an easy task, but we've done it. I think our latest record is we bought 300 subscriptions into an enterprise scale landing zone in the last few months. So there's not a lot we haven't seen. So yeah, we're servant. We'd like to speak to you. If you see yourself in one of the roles Des has just mentioned, hit us up. I'm also on Twitter, although I don't use it that often, but I'm also on LinkedIn. And yeah, it'd be good to talk to you.
Thanks, Nathan. Thanks, Sarah.
No worries. I just have 2 more housekeeping bits to switch to before we hand over to Gary. So let me get to the right bit in my slides now. So tonight's quiz, we are going to do 3 prizes. Usually we just do 1, but we're doing 3 this time round. So first prize, you win a Anchor 6-in-1 kind of USB hub thing, which I think will be quite cool if we do get to actually travel about and we're at offices and stuff, because it'll be able to help you connect all your devices. And get away from our desks. I'm sure you've all invested tons in your home office and now need to replicate that when you travel again. Second prize is a Lego bricks head, I think, for the Star Wars, Mandalorian and Baby Yoda. And then third prize is a £10 gift voucher to the Scottish Bee Company. So we've got a bit of a mix this time in prizes, because I did a poll on Twitter to see if people wanted tech prizes or if they wanted to support Scottish companies. So the vote was pretty mixed, so hence the kind of array of prizes. Now, we do have a bit of announcement in terms of how we're going to run the user group, because we are going to be taking a short break. Usually we run a user group every second month, but I think due to the amount of virtual meet-ons and meetups we've all done, I think we're all a little bit fatigued by that. Plus, with restrictions here in Scotland reducing a bit, it's given the chance to everybody get out a bit of freedom and do what they want to do. So what we're going to do is take a bit of a summer break, and we're going to hopefully come back in October. And fingers crossed, if everything is positive, then we will be hoping to do that in person again. So fingers crossed that happens, but if not, we will be coming back virtually in October, and we'll kick off and keep the community going. In the meantime, please do reach out to us on social media. So you reach out to myself and Gregor and follow us, and we'll keep you up to date with things. We also have the user groups Twitter handle. We have the website, which has been redesigned using the new Azure Static Web App. So that was pretty cool to implement. And we've also got the newsletter, which we'll be using much more during the summer break to keep you up to date, not only with what we are doing and with news as well. And we'll be filtering stuff through then. So hopefully that's okay, everybody. We just thought it would be good to get the summer and try and enjoy it as much as we can with everything that's happening, and then come back in October, hopefully refreshed, and be able to do it in person. But we'll see what the restrictions and certain things are around that. But we'll keep you posted, and we'll figure stuff out nearer the time. So I think that's my housekeeping over and done with. So sorry to get that all done with. But what I'm going to do is hand you over to the amazing Gary, who is going to talk about Bicep and show us what that's all about. Gary, do you want to take over?
Thanks, Sarah. I'll just share my screen. Can everyone see that okay?
Yep.
Cool. So first of all, I'll introduce myself. For those of you that don't know me, my name is Gary Lumsden. I'm a senior customer engineer at Microsoft. I work in the Azure App Dev space. The customer engineer role, the title changed recently. It used to be Premier Field Engineer for those of you who are familiar with the roles at Microsoft. I'm going to be in this role for another couple of weeks, and then I'm going to become a CSA. So adding another string to my bow. I've been at Microsoft for about 20 months now, and before I joined Microsoft, I actually worked at Servant, so I can vouch that it's a great place to work, really interesting projects, fun customers, and Des is a great guy to work for, and Nathan's a good colleague. So definitely anyone that's interested, get in touch with them. Today I'm going to be talking about Azure Bicep, and this is the next generation of infrastructure as code in Azure. So we'll start by looking at what came before, and these are ARM templates, something that I was always a big fan of and really enjoyed working with. We'll then introduce Bicep and look at how it improves on ARM templates. And a bit of a spoiler, in almost every department it improves on ARM templates. After that, we'll look at working with Bicep and we'll have a play with some of the new toys. And finally, we'll have a look at what we can expect to come next from Bicep. So first of all, ARM templates are Azure's native infrastructure as code solution. They're declarative and they use JSON files and JSON structure to define resources, parameters, variables, outputs, and user-defined functions. And there's actually an ARM template language, but it's embedded into the JSON syntax. So an example of that is here, where I've got resource group with these brackets dot location. So this allows me to say the location of this resource is the same as the resource group's location. And you can see the structure here is in JSON, and this is something you've got to handwrite. So how does this work? ARM templates are sent to Azure Resource Manager to deploy the resources that they contain. The way this actually works is each resource is effectively the body that would be sent to the resource provider's API. If I go back, we can see we've got an API version here. So this is really the request body that would be sent to the resource provider. Each of those resource providers we can see at the bottom of the diagram here. So there's compute, storage, network, and lots of other ones. Azure Resource Manager is basically the orchestrator, and it calls each of these resource providers for the resources defined in the template. And Azure Resource Manager will figure out the order of dependencies so that things that need to be deployed first are deployed first. ARM templates can be modularized, but there's a degree of inconvenience relating to this. Until very recently, you had to put linked templates somewhere that they could be read by Azure Resource Manager. So that had to be publicly available. This was typically in a public GitHub repository, or you could use Azure Storage blobs with a shared access signature appended to the URL to provide some degree of protection over your valuable intellectual property. This could be a lot of effort, even with automation. But recently, template specs became generally available, which does improve that story significantly by being able to reference linked templates from template specs, which you deploy to Azure. And you can apply role-based access control to control access to the templates that you've pushed into your template specs in the platform. One of the big challenges with ARM templates is that they're difficult to write. As I mentioned, I'm a big ARM template fan, but sometimes even I got frustrated having to handcraft JSON documents, which, let's face it, should probably be left to machines and to serializers. And working with customers, I've seen a lot of friction in the adoption of ARM templates due to their structure and the unfriendly kind of offering story around them. So ARM templates are the past, but they're also the present, and they'll definitely be the future as well. And I'll explain a little bit more shortly. Okay, so let's dig into the next generation of ARM templates, which puntastically are called Bicep. So Bicep is a domain-specific language, and it allows you to define and deploy Azure resources and their configuration with a rich, readable syntax. The syntactic salt of ARM templates has been replaced by the syntactic sugar of Bicep. The way this works is Bicep adds an additional layer in front of ARM templates, and the tooling works as a transpiler. A transpiler is a source-to-source converter, much in the same way as TypeScript is transpiled to JavaScript. So Bicep files are first transpiled to ARM templates, and then the ARM templates is sent to Azure Resource Manager for deployment. The Azure CLI and PowerShell modules have been updated to allow you to supply a Bicep file instead of having to perform that the build step first to produce an ARM template, which is a nice convenience feature. When you do this, the CLI or PowerShell module will do that conversion on your behalf and then send the ARM template to Azure Resource Manager. When you look in the portal at ARM deployments, you will see the transpiled ARM template. You won't see Bicep in there, at least at the moment. And this is what I meant when I said that ARM templates are the past, but also the present and the future. ARM templates are what Azure Resource Manager understands and will continue to understand going forward. So there were certain goals with Bicep, certain objectives that the ARM deployments team set out to achieve. The primary objective was to build the best possible language to describe Azure resources, define Azure solutions, and validating configurations to deploy to the platform. One of the most important goals was that the tooling was first class and developed alongside the language instead of after the language, which is effectively what happened with ARM templates. Users should be confident that the code is syntactically valid before attempting to build the template to transpile it or to deploy it. Code should also be easy to understand at a glance, straightforward to learn, irrespective of your experience with other programming languages. And this was often a barrier to entry with ARM templates. A lot of people looked at the JSON in ARM templates and found it really difficult to follow. Next, the language needed to provide a transparent abstraction for the underlying platform. So that sounds a little bit markety. So what does that actually mean? It means that there should be no onboarding step to enable Bicep support for either a new resource type or a new API version. The types and the tooling and the language itself should all be independent of one another. Modularization is really important. The industry's been advocating code reuse for years to share best practices, to reduce time to reach a complete solution. But this was always a bit of a challenge with ARM templates. Modularization with Bicep is a huge leap forward. There were also some non-goals, things that the team were not setting out to do. There was no intention that a new PowerShell, a new C# or a new F# would emerge that could be used as a general purpose language to suit any need. This doesn't mean that Bicep isn't going to be extensible, but it will focus on Azure solutions as the first-class citizen, really, and treat that as code with an experience to rival any other way that you can define infrastructure as code for Azure. So some of the benefits of Bicep, and some things haven't changed with ARM templates. They are still declarative, so the syntax is declarative. The same make it so story that came with ARM templates also applies to Biceps. The syntax is so much better. It reads and writes much more like an actual programming language. There's no more noisy JSON stuff going on that came with ARM templates. Just a succinct, readable syntax. No more cursors in the wrong place when Visual Studio Code decides you don't need to fill in the double quotes you've just typed. The story around modularity is way better too. The approach to this makes it possible to break templates up completely, which improves maintainability, makes them much more readable, and promotes reuse. When Bicep is transpiled, the referenced modules are pulled into the resulting ARM template. And the plan going forward is to introduce public and private registries to enable sharing of modules, just as you can share libraries using NuGet or container images using a container registry. And the tooling, in my opinion, is already a step ahead of the tooling for ARM templates. Visual Studio Code is home for Bicep, and with the Bicep extension, there's IntelliSense. There's much better understanding of the API versions, the resource types, better autocomplete. The scaffolding, which has just recently come out, is really powerful. And the coding hints are really useful and make you really productive. There's also the linter, which is new to 0.4, and a linter is a static code analysis tool. And it points out any potential issues right there in the editor, and provides hints to resolve. You can also customize the rules. The linter is also baked into the command line tools. So if you attempt to deploy or build a Bicep file, you'll get warnings, and where you have it customized to do so, it'll provide errors as well. Now, this would be really frustrating if you had to go and rewrite all your ARM templates to start to take advantage of the changes. The good news is there's a converter where you supply your ARM template to the command line tools, and it will turn that ARM template into Bicep. The result might not be immediately sensible in terms of things like resource names, variable names, and parameter names, but the refactoring experience is excellent thanks to strong typing and symbolic names. So why would you use Bicep over other tools, such as Terraform, Pulumi, or Farmer? Farmer's an F# tool that allows you to define Azure infrastructure. Well, Bicep, like ARM templates, has day zero support for all resource types and API versions. There's no work required once a new resource or API version is enabled on the platform for it to be available in Bicep. This compared to Terraform, which requires a provider to be written, which creates a delay, creates a lag between the new type, the new resource type, and the new API being available in the platform to when Terraform can support it. If you're in a real hurry, you can go and write the Go code to support that. It's also free and open source, so there's no license fees. Another advantage is you don't have to have any kind of staging server or jump box to support your infrastructure as code. But with it being open source, if you want to contribute, you're free to do so. All aspects of Bicep are developed in the open on GitHub. And even then, it's completely supported by Microsoft support. So if you've got any issues with Bicep deployments, Microsoft support are there to assist you. Now, anything you deploy in the portal today is deployed using ARM templates. An ARM template can be exported for any existing resources or existing resource group. Or when you reach the end of the wizard, when you're creating a new resource, you can choose an option to export an automation template. This ARM template can then be easily converted to Bicep using the Bicep tools. And hopefully soon, the option to export Bicep directly from the portal will be available, but I'm not sure on that. What's the current state of Bicep? So towards the end of last year, we released versions 0.1 and 0.2, and these were the initial experimental releases, just to get feedback from the community and to encourage contribution to the project. Then in March this year, version 0.3 was released. This release provided almost parity with ARM templates. The only omissions were user-defined functions, which kind of had limited value anyway, and referencing secrets and key vaults, although that could still be achieved using parameter files. And at this point, at version 0.3, Bicep is ready for production and is fully supported. Then earlier this month, version 0.4 was released. This is the first post-production release, and it came with significant improvements to the tooling for Visual Studio Code, including resource snippets, scaffolding, a visualizer, and the addition of a get secret function for key vault, which filled in that gap of referencing key vault secrets. And that's something that was always a little bit cumbersome in ARM templates anyway. Version 0.4 also came with the linter, which includes rules to ensure best practice is being applied in the Bicep code. So let's move on to some of the improvements that you can expect if you switch from ARM templates to Bicep. So one of the biggest improvements is the introduction of symbolic names for resources. Just like you would find in any standard programming language, there are symbolic names for resources, variables, parameters, and outputs. I no longer have to use any cumbersome functions to access any of these types. It also has the advantage of type safety being available in Bicep, so you can't accidentally attempt to assign another resource as the name of a resource. Something I like is the ability to declare stuff anywhere. If you remember the example ARM template I showed you, all parameters had to be declared together, all variables had to be declared together, all resources and all outputs had to be declared together within JSON objects or JSON arrays. If a variable is closely related to a resource, I can now declare it next to that resource. You're no longer bound by variables in the variables objects. Something that I particularly like to do which might be slightly controversial, is to declare outputs at the top of a bicep file, especially where that bicep file is primarily used as a module. And it means I can very quickly open that module, I can see what the outputs are, I can see what the parameters are. The depends on property is gone. So if you are deploying a resource using an ARM template, which depends on another resource being deployed first, so a good example of that is an app service plan. If you're deploying a web app, then you would have to explicitly include a reference to the resource you depend on in a depends on property. This is now all implicit. If you reference a resource within a bicep resource, that's dealt with for you. There is much improved resource referencing because of the type system and symbolic names. You can just refer to a resource as using the name of that resource. There's also vastly improved string operations. Concat and even format were really difficult to read and write, especially when they became complex. There are also improvements to conditions, loops, conditional expressions, all enabled by the cleaner and nicer JSON-free bicep syntax. So in short, so much has improved that it's impossible to cover them all. But I'm going to look at some examples that I particularly like and have made my life easier before we dive into Visual Studio Code and start having a play around. So first of all, parameters. To declare one parameter in an ARM template, it looked like this. We needed to define a parameters object, then the name of the parameter, and then include all our properties of that parameter, including default value, the description, the type. Compare that to Bicep. It's cleaner, it's easier to read, and it's much easier to write. There are also savings in key presses. You've only got so many key presses in your life, so to save those key presses is really important. There's significantly less what I'd consider to be syntactic salt when declaring a parameter in Bicep. Variables in ARM templates look like this compared to Bicep, which isn't quite as dramatic an improvement over ARM templates, but it's still a saving of several keystrokes and some unnecessary JSON structure. Now, the key to Bicep and ARM templates are the resources you want to deploy. A simple storage account in an ARM template looks like this. There are braces, square brackets, colons, quotes, and commas all over the place, referencing the name of the storage account. If you need to get its resource ID or grab some properties from that storage account, requires the use of a function. In Bicep, this same storage account looks like this, which is much more readable. The name, which is this part here, is set using the the name is set using the symbolic name of the variable. So if I go back to the variables section, we've got var storage account name. Now we can just use that. The symbolic name of the resource itself is this part here. The API version doesn't require a separate property and is defined as part of the type. In IntelliSense, the tooling is really good for defining resources when it comes to both the type and the API version. This symbolic name of the resource we can use in other parts of the template. Here we'll only use single quotes for string literals, and we don't need any funky syntax to use functions. We can just use them in line. So, for example, to set the location, we can immediately use resource group.location. When compared to the ARM template version, we need this additional syntax to use that function. So next, string interpolation. The two options for that, there's concat and format. I always preferred format when in ARM templates, but compare that to Bicep and it's just so much nicer. It's better to write, it's better to read, and for those of you coming from a programming language background where the language uses string interpolation like this, like C#, then it's really easy to pick up. Resource IDs. The number of times I've had to revisit a resource ID to figure out that I'd missed a segment, I'd misspelled something, I'd added too many segments, or I'd used the wrong variable is probably uncountable. Look at how much more straightforward it is to reference a resource ID in Bicep. It's more writable, it's more readable. Because the resource has a name, a symbolic name like any other programming language, you can reference the ID directly from the resource object. With resource references, in ARM templates, it looks like this. This line was kind of so long I had to split it to make it readable on the slide. But all this does is gets the fully qualified domain name of a public IP address. Lines like this were difficult to write, but they were even more difficult to read. In Bicep, much like getting a resource ID, we can access the properties of the resource directly using the symbolic name and a dot notation. The last thing I want to compare is something that was always kind of tricky in ARM templates, conditional expressions. Nesting of functions can be a challenge. So we've got an if function, a not function, an equals function, a variables function, and so many brackets to keep track of here. So that could be tricky to write and to read. In Bicep, we can use a syntax that lots of people will be familiar with, a conditional assignment using ternary syntax, just as you can in C#. When I first started using Bicep, I tried this almost instinctively with the expectation that it would work, rather than checking the docs to figure out how you do a conditional assignment. This kind of thing also makes the next person to read my code a lot happier. They can very quickly understand what's going on. So let's jump into Visual Studio Code and the command line and have a play with some of these new toys. So to get started, the first thing you would want to do is install Bicep. The command to do that is az bicep install if you've got the command line installed, but you can also install it independently. So I've got two versions installed. I've got the one integrated with Bicep, but I also have Bicep installed directly on my machine. I always use the Azure command line integrated version of it. If Bicep needs upgraded, all you do is use the az bicep upgrade command, and it'll go away and figure out if an upgrade is required and install it automatically. So it's really easy to keep the tooling up to date. In Visual Studio Code, there's an extension for Bicep. So you could search for Bicep here and then install the extension here. This comes with all the nice stuff like linter integration, IntelliSense, scaffolding, things like that make it a really good experience to use Bicep. So let's get started. Let's go into our first Bicep file. And I'm going to add a storage account resource first of all. So I need a resource. I'm going to call it storage. And straight away we get a hint of all the resource types that are available. So search for storage account. And as soon as I press tab, I've got a list of all the supported API versions. So I can now press tab, equals, put in my braces, and then I can start to define my storage account resource. Alternatively, we can allow IntelliSense to say, well, the platform knows what the required properties are, so let's just put the required properties in. So let's call this GUG storage. I want it to be in the resource groups location. The SKU, I think we'll just go with standard, locally redundant, and the kind is storage. That's all we need to do. This isn't particularly good practice though, so let's change this to a variable. And I can define the variable, again, anywhere in the file. Make that a string equals What have I done wrong? Don't need to type there. So now we're using a variable here. Maybe not a good idea to use a kind of fixed name in the for the name of the storage account. So let's introduce a parameter called prefix, which will be a string, and we'll call it AUG. So now in here, I can change this to say prefix, and then storage. And then if I want to make sure this is always going to be unique, I can use the unique string function on the resource group ID. So now this will almost certainly deploy with a unique name. If we want to add a description to this parameter, this is easy as adding the description there. So now that we've put together our Bicep file, let's build it and have a look at what the result is. So our output is this basics.json file. Bicep adds some metadata here, which isn't overly important, but we've got our parameters here. The string interpolation here gets turned into this format function call. The type and API version are separated, and straight away we can see where the tooling excels in Bicep. The ARM tooling, the ARM template tooling, doesn't see this as a valid API version. But we know it is because Bicep is pulling that from all the Swagger documentation in the platform. So in Bicep, these are symbolic names. So I can navigate around this file using Control and click. So that was nice and easy to set that up, but it can be made even easier. So let's say we want a storage account. All I have to do is type res-storage, press tab, and I've got the scaffolding of my storage account set up already. So this will be storage account name, storage, standard, and standard. So as quickly as that, the tooling helps you to build these templates. Now these snippets are available in GitHub, so you can contribute to them. So they're all in here, and there's also a contribution guide if you do want to contribute some snippets. Okay, so next I want to look at the linter. So this is a Bicep file that I wrote previously, and we can see we're getting warnings here from the linter saying we've got an unused parameter here, or we've got a secure parameter here that is defining a default value, which turns out isn't very secure. I'm getting a warning here saying that I don't need to interpolate this, and in fact I can just press Control and dot and choose remove unnecessary string interpolation. On this one, again, we can say use string interpolation. So I'm using concat here. There's no need to do that. We can just use string interpolation. And here I'm using format. Again, don't need to do this. We can use string interpolation. That might be a bug. If I come into the bicep config.json, then I can say that no unused params should be an error. So save that and come back in here. Save this file. I might need to reopen it. Then my unused params are errors now. So this means that even when you're doing a deployment using the command line or CI/CD, then your deployment will fail based upon the bicep config.json file that's here. So as I mentioned, that it's going to be really valuable to adopt Bicep by decompiling your existing templates. So I've got a simple ARM template here, which deploys an Ubuntu virtual machine. And this actually comes from the quick start templates. So I could come into my command line and say AC Bicep decompile. Then we can come in and have a look at the Bicep file. And it's done a pretty good job here. So we've got our parameters, our variables, and our resources. So as like I mentioned, the result isn't going to look particularly good initially because of the way it infers the names of resources and variables. But what I can do is change the name of the network interface by removing name there, and then update this variable so that it's not suffixed by var. And because it's all strongly typed, the editor gives you hints along the way, then it's relatively straightforward to perform this refactor. So fairly quickly, you'd be able to turn this into a nice readable ARM template, Bicep file, but it would also be immediately deployable as well. So another feature is our modules. So I've got this main.bicep file here. And I've got a storage module here. So this storage module can be reused by anything that requires a storage account that is deployed with this configuration. So we've got a parameter. This is a required parameter because we've not supplied a default value here. And we've got an output. So we're outputting the storage, the primary blob endpoint of the storage account. So now I can come back into my main Bicep file and I can say module, storage, and then automatically it's picking up the other files and directories that are in this path. It equals, use the tooling. I'll add the required properties. So it's reading this Bicep file to figure out what I need to pass in. So I could see GAUG as my prefix. All this storage module deployment. If I come back in here and add another parameter, then when I come back into main.bicep, the linter has picked up the fact that I've missed a parameter. So I'll take that out for now. And we'll come back into our command line. And we'll say AC bicep build. So that'll be 3. And when we look at the ARM template that's created, the only resource in here is a deployment. So this is how modules are pulled into ARM templates. They're pulled in as separate deployments. So this storage.bicep module is transpiled to an ARM template, and it's injected into this deployment within the ARM template. So any Bicep file can actually be a module. So that allows you to have lots of building blocks, so various levels of complexity when building your infrastructure as code. So now on to conditions. So in here, we've got a storage account. And I want to deploy this conditionally. So I can say if deploy storage. And I'll add a parameter for that. With a default value of false. So this condition, again, a lot easier to write than in ARM templates, and a lot easier to read. You can very quickly look at that and see what the condition is. Add another parameter here. So the allowed storage kinds. And in here, I can use this directly. In here, I can use that ternary syntax. So I can say storage kind is storage. Oops. Then we're going to be standard. Otherwise, it'll be premium. And we could do the same for the tier. So instead of having this hard-coded here, it could be dynamic. So it's much nicer to write these conditions now. Save those changes and I'll build that again. And we can compare what that looks like in the ARM template. So we've got the condition here, which is relatively straightforward, but again, it's got that kind of syntactic salt. But here we've got the nested functions. So we've got if, equals, and parameters are all functions. So much easier to read, much easier to write in here. We can also have a condition on outputs. So here I'm going to add an output called lob endpoint, and we can say if deploy storage is true, then storage account.properties.primary endpoints.blob. Otherwise, nothing. If I do the compilation again, then we can see how this condition is expressed in the output. So next on to loops. So again, we've got a storage account here, and to turn this into a loop, all we need to say is for I in range. So let's deploy 3 storage accounts. And square bracket goes down at the end here. Oh, missed that colon there. So straight away we can deploy 3 storage accounts, and this I will give us the index of the current instance of the copy. So using string interpolation, I can add that in there. So if we build this one, you can see how the copy is expressed in the ARM template in JSON. We've got another option, so we can add a variable. So what I'm creating here is an array of storage names. This time I want there to be 4, and I don't want them to start at 0, so I'm going to add 1 to the name each time. And now I can change this to for name in storage names and update the name here to name. That again. And we can see how it's changed. So now we're doing the count of the copy is using length. So it's still effectively an index-based copy in the ARM template, but it's expressed as effectively a for each in the ARM template. This is probably more similar to Java for each than C#, for example. It's also possible to get the index of the copy when using this for each type syntax. So if you need the name as well as the index of that name in this array, then you can get that as well. But for now, I'll just go with the name. And then finally, we can add an output. We want to output each of these blob endpoints. So I'll say output endpoints, which is an array, and that's going to be a loop. So for I in my cursor. There we go. So we can see that we can access the storage account using its index. So we can use this symbolic name for the resource copy to access the specific instance within the array. So there's something kind of important that we've not done yet, and that is to actually deploy a Bicep file. So I'm going to do that now. So using the EZ group deployment create, in fact, I think this is the deprecated command. It is. So this is going to go and kick off a deployment. So if I open up, let's zoom in here a little bit. So this is the deployment that's kicked off, deploying 4 storage accounts. And we can see the template that's been passed to Azure Resource Manager isn't Bicep, it's an ARM template. Shouldn't take too long. There we go, it's done. And we can look at the output, and I'll need to turn off my mask. And we can see that array of blob endpoints now. So that would be available as the output from that deployment. So the last thing I want to look at is existing resources and secrets. I decided to put these together because referencing an existing resource is something that's really useful. And is also required when you use the new get secret function that's available on key vaults. So I'm going to add an existing resource, which is a key vault. So say resource vault, and that is a key vault. And I'll use the latest GA. And using the keyword existing, I'm telling Bicep that this is an existing resource. And the name is the vault I prepared earlier. So this is all you've got to do to reference an existing resource. Important to note that it's within the scope of this this deployment. So if the resource group, if the deployment is resource group scoped, then this would have to come from that resource group. But you can scope differently at subscription level, etc. So this is how you would reference any existing resource, whether that is a virtual network subnet, existing storage accounts, any of those things that tend to be shared platform resources, things like log analytics workspaces. This is how you can reference them in Bicep. So now I'm going to add a module. And my module is getsecret.bicep. So I'll call this and I'll say the name of my secret is deployment secret. So put that in there. So what I'm doing here is I'm invoking a module and I'm passing a secret which exists within this key vault resource. And I'm going to add an output, which is, I'll change that. There we go, which is the output of this module. So we'll take a quick look at this module. And all we're doing is using this to allow us to pass the secret in and pass it back out. You can only use getSecret in the context of passing a parameter into a module. But because it's so easy to modularize Bicep, it makes it really easy to grab these secrets from your key vaults. So if I do a build, and it's called main. So again, we can see that there's a deployment, and we can see the key vault reference syntax for passing secrets to nested deployments or linked deployments in ARM templates. So now I'm just going to deploy that. So he said, in fact, let me copy the command from a cheat sheet. This should run relatively quickly because there aren't actually any resources to be deployed. So let's come out of here. Here we go. And we can see in the outputs, if I turn off my mask again, that the secret that I have in Key Vault is hello Glasgow Azure User Group. So that's a kind of a quick overview of some of the new toys that are available in Bicep. So Bicep is pretty mature today. The tooling's good, the authoring experience is good, and the support in the platform is pretty good, but there is more to come. So today we're at version 0.4. Oops. But in the next version, which is hopefully going to be around August, version 0.5 will introduce public registries to allow Microsoft and the community to share canonical modules for resources. And we'll also introduce the private module registry for teams and for cloud centers of excellence to allow modules to be shared internally to an organization. And this will be awesome for code reuse. The next version of the linter should have parity with the ARM template testing toolkit. It doesn't quite have all the same rules that the ARM TTK has today. And the aim is also to allow extensibility for custom rules. These will either be separate based on config or to contribute back to the core rule set in GitHub. One area that would make Bicep even more awesome is passing resources between modules. It's not something you can do today, but it would help so that you don't have to pollute Bicep with some of the old syntactic salt and boilerplate that you need to use to work with resources that are created by the module. So for example, you might still have to use resource ID, or you can get the module to return the resource ID. It's worth having a look at the GitHub issue for passing resources between modules, but set aside maybe an hour or two. It's enormous. It's actually been split into 2 issues, but it's worth a read. There will also be load text content, and this will allow loading an external file, which will be useful for things like scripts and cloud init. And the real value here is the file will be imported properly escaped. So you won't have to fiddle with getting your script working and then figuring out how to escape it properly to embed it in your ARM template. One thing I can think of that this would be really valuable for are stream analytics job queries. At version 1, all breaking changes will be strictly controlled. You can be confident at that point on that your Bicep implementations will continue to work. With that said, I foresee very few breaking changes from today. There were a few between 0.1, 0.2 to 0.3, but I can see them being fairly few and far between, given that a lot of organizations will have adopted this for production. Updates for Azure types will also be decoupled from the Bicep tooling. This allows the constant change that takes place in Azure to be reflected in your tools without needing to actually update those tools. And another really exciting one is the capability for deploying non-Azure resources. At the moment, it's very much Azure resource specific, but this change won't necessarily introduce anything goes extensibility. It will still be focused on deploying Azure solutions. Azure solutions is the domain that this domain specific language covers. So it'll be things like creating Azure AD objects or Kubernetes deployments on existing clusters. Some resources that are worth having a look at to get you started. The first one there will take you to GitHub, where there's a lot of information, the full language spec. Bicep docs are where you'll find the documentation in docs.microsoft.com. And Bicep demo will take you to a playground. So I can give you a quick look at that. Demo. And what this gives you is a playground where you can experiment with Bicep and see what happens to the ARM template, or experiment with the ARM template and see what happens to the Bicep. You can pull in quick start templates as well to have a play around with those. That went well. Oh no. There we go. This one works. So a good way to have a play around with Bicep, get used to the language, is to use the Bicep playground. There's also a learning path. So there's a beginner learning path to help you get up to speed. And all the news and important updates will also be on Twitter on Bicep Lang. So thanks for listening to me today. I should also extend a thank you to Alex Frankel and the ARM deployments team for sharing their early work to learn with, and for sharing the material upon which some of this presentation has been built. And I loved ARM templates, but Bicep is the leap forward that I didn't realise that I wanted or needed. If anyone has any questions, I'd be happy to answer them now. And thankfully, yeah, my Bicep wingman Paul is still on the call if I don't know any of the answers.
Thanks for that, Gary. That was really good. There is a few questions we've had in the chat while you've been talking. I think some of them have been answered, but potentially not. Chris has been asking about the get random PowerShell command, which helps to kind of randomize your, say, storage account name. I'm not sure if he's been able to find an answer, if we can do that in Bicep or not. Have you had that?
Yep, so you can do that. Where's Visual Studio Code? I think I did it in the first demo. So using this unique string function allows you to generate a 13-character unique value. Now, because ARM templates and Bicep need to be idempotent, it's unique but deterministic. So if you pass in the same resource group ID as the argument to unique string, then you'll always get the same unique string. But there's a very high chance of that being random. Another option you have is if you say param good equals new good, then that'll give you a unique string value as well. Albeit with storage accounts, you would have to do some work on this to replace. In fact, you'd probably have to define it as another variable, but you'd have to replace the dashes because storage accounts don't allow dashes. You'd also probably want to trim it because of the maximum length of a storage account name. But the approach I've always used with success is unique string. And by passing in the resource group.id, then it's deterministic and always the same for the same resource group, but you can deploy to a different resource group and be guaranteed a different unique string.
Thanks for that. Appreciate it.
Cool.
Awesome. I think there's another question as well from Matt here, asking about occasions where you would actually use ARM templates instead of Bicep, Gary. What's your...
Yeah, good question. I can't think of any just now. I don't think so. I don't think so. That said, so I don't work with Bicep and ARM templates in anger on a daily basis like I used to when I worked with Des. So I might come across some edge cases in due course, but I can't think of any at the moment.
Answer still no, Gary. Crack on and use Bicep.
Absolutely.
I guess that's a good point though. And if you haven't learned ARM templates, or you maybe just dabbled enough to get by, much like myself, to be honest, is there much point in even learning ARM templates these days, or should I maybe invest in learning Bicep properly?
Yeah, go straight to Bicep. You know, if you were a web developer, you'd probably go straight to TypeScript. Especially in the Microsoft world, there's little point in learning ARM templates. Go straight to Bicep. The only scenario where that could be valuable is if there's maybe a problem with the transpilation. So the transpilation's a mouthful. I'll say compile, but it's actually it's transpiling. So you'd be able to dive into the ARM template and figure out what's maybe gone wrong. That's where having a good foundation in ARM templates can be really valuable when working with Bicep, but it's not something I've come across very often. Although I'm going to go back and take a look at some of those quick start templates to see why they couldn't decompile.
I suppose at that point, if you didn't know ARM templates and something didn't, what was the word you used there? I'm not even going to say it, transpile. I think that's what you said, Gary.
Yes.
Into ARM templates, that's maybe a case where you would actually reach out to the team themselves and be like, what's going on here? Is this an edge case, or have I done something wrong?
Yeah, there's also a support ticket through the Azure portal. Bicep's fully supported now, so it would be, you'd be able to get a resolution, and where required, it would probably be escalated up to the product group.
Yep. Chris is actually making a point here that probably ARM templates still being included in exams, and I guess that's probably around exams are more focused on fully GA, fully generally available products. And I think you were saying there, Gary, if I'm right, Bicep, although it's production supported, it's maybe not fully GA. Is that right?
So it's a slightly grey area.
Yeah.
It's fully supported by support, and it's considered production ready, but I don't think they're using the term GA until it reaches V1. But for exams, ARM templates are probably still going to be important, at least until the next versions of all the exams are updated to include Bicep instead. So Bicep is going to be put front and center as infrastructure as code for Azure.
Yeah, awesome. Gregor's asking about the 101 kind of gallery that we have on ARM templates, which is an amazing resource on GitHub. Do you know if they're going to do away with that or change it or update it? I'm guessing that's
So I believe it's a work in progress. So just for anyone that hasn't seen this, there's a resource on GitHub with lots of quick start templates. I believe some have already been converted, but there's a big push both internally and from the community to start to migrate these over to Bicep. So a while since I've looked at these, but when we move on to the quiz, I'll have a look and see if there's a separate repo or if they're also in this repo. They might actually be in here. I'll have a proper look once we move on to the quiz and things.
Awesome, excellent. Does anybody get any other questions? Well, Gary's here. All good. All good. Awesome. Thank you so much, Gary. That's really appreciated it. You've answered a lot of questions for me because I haven't really dived into Bicep at all at the moment. So yeah, awesome. Thank you so much, everybody. If we've got no other questions or comments or whatever, we'll probably move to the quiz, people, if that's okay. Thank you also to Gary for hanging around and doing the presentation. That's been awesome. As I said, we're going to be taking a short break until October, when we'll hopefully be able to do a meetup in person, but we'll see what happens and see what happens in terms of restrictions and what we have to meet to make that happen. But please do follow us on Twitter. Please do take subscribe to our newsletter. We will be keeping in touch, and we'll hopefully be able to catch up with you all very soon. So thank you so much, everybody. Really appreciate the support, and keep in touch.